Okay. So yesterday, what was the last concept that we saw? We saw for an equatorial point, right? Electric field due to a dipole at equatorial point. Yes. So in the previous scenarios, what is that we focused on? We were focusing on if a system of charges is given to us, then how is the electric field due to that system going to be? Right? Especially we focus more on dipole because dipole has an application in the next chapter. Right? Under a topic called as capacitors, there we'll be discussing about dipole in detail. In detail, in the sense, we'll see where it is applied. Okay. Now, the next question is, if I have an electric dipole, I know that electric dipole will generate electric field. But what about an electric dipole placed in the field generated by someone else? So that's the meaning of this topic. So if you try to look at the topic and dissect it into smaller parts, you will understand it better. See, torque experienced by a dipole placed in uniform electric field. The meaning of this, okay. You're able to see any pencil? Huh? Yeah. So when it is placed in uniform electric field, first let's try to understand what does this uniform electric field mean in the first place, right? So we already discussed what an electric field is. So if I take a positive charge, due to this positive charge, how is the electric field going to be? It will be in the radially outward direction, right? So if I put a question like this, is this kind of an electric field uniform or non-uniform? What will your answer be? We think it is uniform, no? But actually it is not. Because uniform means what? It's same. So when you say that the electric field is supposed to be same, it needs to have the same magnitude and same direction. But if you see here, it is having random direction. So we know this fact, right? What is the electric field due to this kind of a charge at different locations? E is equal to kq divided by r square, correct? So as the value of r is changing, the value of electric field is also changing, right? It keeps changing, meaning it is not going to be uniform. So first thing to be wiped off from your mind is this is not a uniform electric field. Then the question is, how does a uniform electric field even look like? So what did I tell you? It's very simple. It needs to have same magnitude and direction. That is only possible when you have a set of parallel lines. So this is how a uniform electric field is going to look like, where this electric field has a magnitude of E. Am I clear? And in this, what is placed? What is this? Dipole. What is a dipole? Dipole is basically a positive and a negative charge of the same magnitude separated by a very small distance. Right? Now, I'm going to understand the concept from here. Why are they even saying torque experienced by dipole? Let's see first of all what they are actually trying to convey to us. Right? What is this scenario going to tell us? Right? See, in physics, there are only two things that you need to concentrate upon. One is called as force, and the second is called as torque. Force is the one which is responsible. If you have an unbalanced force acting on a system, it experiences translational motion. What is translational motion? If this pen is there, something moving like this is a translational motion. If it has an unbalanced torque, it experiences rotational motion. So here the topic says torque. Let's try to understand why they are speaking about torque. Right? For that, one fact that I need to understand is if I take this to be plus q, this is going to be minus q. That's what a dipole is. Right? So we know this value E is equal to F divided by Q. Am I right? So that's what the basic definition of electric field tells us. See, this is the value for a point charge, whereas this is the basic definition of electric field intensity. Then if I write F, how do I rearrange it as F is equal to Q into E. Now tell me, among this force and electric field, which one are vector quantities? Force and electric field, they both are vector quantities. Now tell me one thing. Who will decide the direction of force? I will be able to tell that the force and the electric field have same direction if the charge is positive. Whereas if the charge is negative, the force and electric field will be in opposite direction. Why am I even speaking about it? Listen, this is where you will understand. Concentrate. This positive charge is there, no? According to this concept, in which direction will this positive charge experience force? It will experience in the direction of electric field. Just now I told you, no, positive charge will experience a force in the direction of electric field, whereas a negative charge will experience a force in the direction opposite, meaning this will experience a force in this direction of how much magnitude? Concentrate. So it will be Q into E only, but in the opposite direction. Am I clear with this? Now tell me one thing. What is the net force acting on the system? Why? Because this is acting in the positive x direction, this is acting in the negative x direction, and they have the same magnitude of how much? QE. So QE plus of minus QE will give you a 0. So the net force acting on the system is going to be a 0. Meaning it will not move at all. So that's why the topic didn't speak about force. They spoke only about torque. Now we need to answer why this torque is coming into picture. Suppose this is the dipole. Okay. How is one force acting on it? You can exactly relate it. I took it from here. One of the forces is acting in this direction. So you can try with your pen and see. You hold the pen at the center, right? If you apply a force here in the tangential direction, in which direction with respect to you is the system tending to rotate? Which one? Clockwise. So it is like this. It is rotating clockwise because this force is acting in this direction. The bottom force is acting in this direction. So if I hold this pen, let's say, okay, just hold it, no? Or you hold your pen. Just hold it. See, one force acting like this, the other force acting in this way. You are able to see that the system is revolving. It is revolving in which direction? Clockwise direction. Now, this is where I want you to concentrate. Let's take the example of this water bottle and understand. Okay. So how do you open this? You rotate it anti-clockwise when you see from the top. So when you rotate it in the anti-clockwise direction, is the cap traveling towards you or away from you? Towards you. So anything that is traveling towards you is considered to be positive. Anything that is traveling away from you is considered to be negative. Same as the case with respect to a screw. You're able to see the screws here, right? When they want to do it, you take a screwdriver, you turn it in the clockwise direction with respect to you, it will go into. Means you're drilling into the wall. If you turn it anti-clockwise, you're taking it out of the wall. This concept is clear. Meaning of this is, there is a reason why I'm talking about it. Though we have a system of unbalanced forces, still the object need not have a translatory motion, but it can have a rotational motion. And in this case, in which direction is it revolving? Clockwise, right? So one point I want you to register in mind is anti-clockwise moments are negative. What do I mean by anti-clockwise moments? Sorry. Anti-clockwise moments are positive. What do I mean by anti-clockwise moment? When you rotate anything, any screw in the anti-clockwise direction, it always tends to come towards you. Right? Similarly, you have clockwise moments, which is going to be negative. Am I clear with this? So you rotate anything in the clockwise direction, it will always travel away from you. Having said this, if the system is allowed to revolve, in which direction do you think it will tend to move? Will it move into the plane of the board or out of the plane of the board? Into, because it is rotating in the clockwise direction. Means if you rotate it like this, no, it will appear as if it is going into the plane. Okay, so have this in your mind. So is this point registered in your mind? Right. So three important points I want you to understand. Did you understand why this QE came? Directions are clear, right? Did you understand that the net force is zero? Second point. And did you understand the system is not having net force, but it is having a torque due to which it is revolving. Now our job is to calculate the torque. Now I'm coming from your 11th standard basic, torque in the vector form is written as R vector cross F vector. Right? This is when you write it in the vector form. Whereas if you write the same thing in the scalar form, right, you write it as you cannot have cross and dot at the same time. Fr sin theta, okay. They say something like force into perpendicular distance. Have you seen this? So force into, you write it as perpendicular distance, meaning whatever force you are applying, from the point of application of force to the axis of rotation, find the perpendicular distance. So whenever you talk about rotational motion, right? See, there is a difference. Okay, I want you to concentrate on this. There is a difference between rotational motion and circular motion. Can someone tell me what is the difference? Rotation and circular are not same. Not necessary. See, fan is rotating. You say fan is rotating or revolving mean the same. Can you give me a more precise thing? I'm not concerned about this kind of a comparison. Very good. That is one of the points. You were about to say something. Since you mean to say in rotational motion there is no centripetal force. Point is, whenever you talk about rotational motion, right, you speak for a rigid body. Whereas when you talk about a circular motion, you speak for a point object. That is the first point to be noted. So when you speak for a point object, right, you do not define something like how she told it's a perfect point. You do not define the axis of rotation at all. For a circular motion, you define the center. For rotation motion, you define the axis of rotation. Meaning, if you take this fan into consideration, this fan is revolving about an axis that is the rod itself. Am I clear with that? In a similar way, when this system, if I am saying it is revolving, I am not saying it is in circular motion. Understand, this charge and this charge are in circular motion, but the system as a whole is in rotational motion. Minor point, but are you able to understand this? So what did I say? This charge and this charge, point charges, are in circular motion, but the system as a whole is in rotational motion. For that rotational motion, I need to define the axis of rotation, meaning it is revolving about this axis, means the whole system is revolving about an axis that is going into the plane and coming out of the plane. It's an imaginary line that we need to visualize. Am I clear with it? Having said this, force is there, no? Force into, I'm talking about perpendicular distance, no? So what is the perpendicular distance I'm speaking about? See, let's take a very simple example. Give me your book, no? Give me your book. How do you open this? You flip it. When you do, even without your knowledge, what you're doing is, you don't, have you seen anyone holding it here and opening it? Without your knowledge, what do you do? Without your knowledge, you're used to a comfort. You put your hand here and open it. Well, you find that's how your subconscious mind works. Right? You open it like this. Actually, what are you doing? You're actually rotating it. So you apply force here, no? This force is acting at a perpendicular distance from this axis of rotation. So it's happening like this. Am I clear with that? So the point of application of force multiplied with the perpendicular distance from where, whenever you speak about distance, either you need to define it from a point or a fixed line. Here it is a fixed line, that is axis. This force into perpendicular distance will give you the amount of torque that you applied. If you apply it from here, you can apply less force to open it. Whereas if I put a pin here and I ask you to open it, right, compared to this position, you will feel slight difficulty at this point. If I bring it even more close, means to generate the same torque, since the distance is reducing, you look at it, it's a product. Since the distance is reducing, to generate the same amount of torque, you need to increase the force. That is why all the hinges are for the doors are kept at the end. They could have put it at the center. That's the reason everything is kept at the end, because it's simple for you to work. Are you able to understand? So I want this point to get registered. Is everyone clear with this? I'm talking about scalar quantity. So point of application of force is here. From the point of application of force to the axis of rotation. Now see, tell me one thing. How much is this distance? See, the total distance is taken to be 2a. Then how much is this distance? It is going to be a. This is going to be a. Right. Now, this is the axis of rotation. From here, I am drawing an imaginary line. And if I take this angle to be theta, right, then this A can be broken down to horizontal and the vertical component. So if I take this to be y, what is y divided by a according to trigonometry? Y by a is what? Then what is the trigonometry? It is sine theta. So y is equal to what? A sine theta. Then what about this case? This is theta. Vertically opposite. Oh, sorry, not this one. I'm sorry. Not this one. If I drop it here, this will be theta. Right. This is still A. Then how much will this be? No, if this is theta is here, opposite. So it will be A sine theta. Now listen to this carefully. If I use this formula, torque experienced by the positive charge is how much? Force, how much is the force acting on it? You have the answer there. What is the force acting? Try it. It's there. You are able to see the value. I wrote it. No. Connect the dots. F is equal to QE into what is the perpendicular distance? From here to the axis of rotation, what is the perpendicular distance? A sin theta. That's it. Right. Now torque is a vector quantity. I told you, whenever you deal with vectors, first write down the scalar, then we'll break our head for the direction. So if I put an arrow mark on top of it, right, I need to assign a direction to it. Now tell me that QE is making the system revolve in which direction? Clockwise. What did I say clockwise is? Clockwise is negative. It is away from you. Right. When you're seeing in this direction, if I take this to be the x-axis, this to be the y-axis, then towards you will be positive z-axis, away from you is going to be negative z direction, right? So when that is going to be negative z direction, what do I write the value as? Minus k cap. Makes sense. It's a simple point, but are you able to understand what I'm trying to say? Right? Now, if I take the torque that is acting due to the negative charge, yes, I Kalyan, right? Yeah, can you try? Just try, even if it is wrong, it's fine. So tell me what is that you're supposed to write for force. I'll tell you what I'm asking. Okay, this is a negative charge. This negative charge is experiencing a force. What is the value? It's there on the board, nothing is out of this QE, right? So what should I write here? No, I'll write only QE because I've already assigned the direction. Okay, then what is the perpendicular distance from here to the axis of rotation? That also I've written on the board. That's it, perfect. Right, this is the scalar part. Now what should I do? I need to write the vector part for it. You complete it, no? Yeah, Tejas, have any question? This this QE and this QE put together is revolving the whole system in which direction? Both are making it revolve in clockwise direction. Had it become plus K, right, then torque would have got cancelled. It is minus K cap. Am I clear with this? So here also it is minus K cap. Simple, no? Right? If you stick to the basic, it's simple. It's only 2 steps. See, I was telling so much of story, but if you look at the number of steps, it's only 4. Right? So what is going to be the net torque? Positive charge plus torque due to the negative charge. So they get summed up because they both are in minus k cap direction. So what should I write? QE, if I take it out, A sin theta plus A sin theta is going to give me a 2A sin theta with a minus k cap. So this Q into 2A is going to give me This you already know, dipole moment. So this is going to give me dipole moment Pe sine theta with a negative of k cap, and this is going to be the net torque acting on the system in the vector form, right? So first copy it till this step. I have something important to tell you after this. So if you see the net value, it is going to be Pe sine theta with a negative of k cap. Okay, accepted. Now, suppose I have C vector is equal to AB sine theta n cap. That's what the cross product says, right? So then I don't know whether C vector is actually A vector or cross B vector or B vector cross A vector. It makes a difference because they both are not same. What is the relation between them? A cross B is the negative of B cross A. They both are always in opposite direction. So taking the idea from there, here I have P sine theta minus k cap. N cap is a unit vector. Okay, here instead of n cap, I have minus k cap. The question is, I can either write this Pe sine theta as P vector cross E vector or E vector cross P vector. Which one should I choose? Are you able to understand my question? I can either write it as A cross B or B cross A. I don't know the answer here. Right? So what should I write it as? So the net torque, what should I put here? Let's try to understand this. Tejas, any idea? Give me 2 pens, no? Give me a pen. Okay. See, if I have one vector like this and another vector like this, let me call this as A vector, this as B vector. So what are the two operations that we can do? We can do A cross B or B cross A. If you do A vector cross B vector, listen to this carefully. If you do A cross B, A is the first vector, B is the second vector. So when you're doing A cross B, then you need to fix the direction of B vector. You need to fix the direction of second vector and rotate the first vector towards the second vector in the shortest direction possible. Meaning, if B is fixed, this is A, this is B. If B is fixed, I need to rotate A towards B in the shortest direction possible. I can either revolve it like this or I can go like this and come like this. So, which is shortest obviously according to you? So, first one, so this direction is shortest, right? When you see from that side, what is the direction in which this pen is revolved? It is anti-clockwise. And what did I tell you is an anti-clockwise moment? Positive, meaning the cross product of these two will have this n cap towards you. A vector cross B vector will have the n cap towards you. Whereas if I do B cross A, then what is the logic I need to use? Fix the direction of the second vector in B cross A, which is the second vector, A. So fix the direction of A, rotate the first vector towards the second vector in the, that word I need, in the shortest direction possible. So when I rotate it in the shortest direction, according to it is clockwise. So clockwise moments are negative and they are away from you, right? So I don't know whose pen, you take it. So having said this, if I go back to this diagram, right? If I go back to this diagram, what is the direction? What are the two vectors involved? Dipole moment and the electric field, Pe sine theta. So what is the direction of dipole moment here? Direction of dipole moment, right? Direction of dipole moment. Check your notes yesterday. Check your notes of yesterday. It is always from the negative to the positive charge. So this is the direction of dipole moment and this is the direction of electric field. So if I draw a free body diagram of P vector and E vector like this, right? So P is like this, E is like this. I just took the diagram and drew it. I didn't draw the random directions. Now, if I take this as A and this as B, suppose I do P vector cross E vector, then what should I do according to the concept that I explained? I need to fix the direction of E vector. So this is fixed. Which one should I rotate? P vector towards E vector in the shortest direction possible, rotate it in this direction, and then what will happen? So it is negative, meaning minus k cap. So what should I write here? I should write it as p vector cross e vector because the net torque that is acting is in the inward direction. Are you able to understand? See, I could have directly told you accept it as p cross e, but I want you to think. Is that clear? So just because I wrote p first, no, I could have told it. Just because I wrote p first, write it as p cross e, but that's not the case. You need to know the reason for it. Am I clear with this? Next time, wherever you see cross product, will you be able to think in these terms? So this is the torque that is experienced by dipole, which is placed in uniform electric field. So when you place a, first listen, then you can write. When you place a dipole in uniform electric field, what is there? Force is 0, torque is not equal to 0, and its value is p vector cross e vector. Now I have a small question. Instead of they giving it as uniform electric field, had they given it as non-uniform electric field. Non-uniform electric field, you don't have the derivation, but you need to understand the concept. So had they told the same dipole is placed in non-uniform electric field, then what do you think would be the changes? Force also would have not been equal to 0, and torque is also not equal to 0. Meaning, in this scenario, in the first scenario that we discussed, the dipole will rotate about a fixed axis. It will be like this. Whereas in the non-uniform electric field, it will rotate as well as translate. It will keep going like this. So it will rotate and keep going like this. Are you able to understand? Means it has both translatory motion and rotational motion. See, next time onwards, wherever I see the word torque, I will not explain this much at all. I'll directly go into r vector cross a vector, give you the derivation. So is everything clear? Right? So please make a note of it.